Hi, my name is Marwa Mahrouqi, and today basically I decided to teach you some of the concepts and ideas that I have learned while working as a chemical engineer. So I will start with a very core concept in the industry, which is known as piping and instrumentation diagram. If you are someone who are just graduated from university, you might be familiar with the idea of block flow diagram, process flow diagram, and P&ID. Especially for a chemical graduate, this is very essential for you to tackle your design courses. However, the idea today is basically to give you a very generalized understanding as someone who worked in the industry. So whether you are placed within the design team, whether you are placed within the operation, those key concepts basically will help you to grasp some of the core ideas. So we will start with the lesson objective. So the lesson objective of today's session is basically to develop a very generalized understanding of P&IDs, and then we will look into the P&ID milestones. So how the P&ID is being constructed within the different project gates, and also the anatomy of the P&ID. So you have different elements within the P&ID. So how to read them, what do they mean? So this general understanding is very important. And another objective is basically the difference between block flow diagram, process flow diagrams, and the P&ID. So we will start the session basically with the diagram that I have illustrated here on the top right, which shows you the block flow diagram. And the block flow diagram is basically the simplest form of diagram that you have. It consists of series of blocks. It's a very simple diagram that gives you very good generalized understanding. And then more detailed diagram after the block flow is known as the PFD, or the process flow diagram. Another more detailed diagram, which is the most detailed diagram that you have for your chemical plant, is known as pipe and instrumentation diagram. Also it's a P&ID. So a P&ID is basically a blueprint of all of the elements that is in your refinery or chemical plant. If there is any flange, any mechanical connection, any manway for the vessel, all of those elements should be included in the P&ID. So we will start with the understanding of block flow diagram. So a block flow diagram, from its name, it is consisting of blocks. That's why it's called the block flow diagram. And basically, if the idea of the block flow diagram is basically to ease understanding. So if you are someone who's basically new in your job, you have been employed very recently, you might be presented first of all with the block flow diagram so let's say, for example, you are employed into a refinery, then you will get a block flow diagram of all the units inside the refinery. So for example, CDU, VDU, hydrocracking units, how those units are basically connected together. So any units which exist inside the refinery will be within the block flow diagram. And also sometimes block flow diagram is also used to present to non-technical staff. So you have someone who may not be familiar visiting your plant, and you want to show him what's the issue, or to ease his understanding, show him how the units are basically connected together. And a block flow diagram is very helpful in those cases. And if you are, for example, now selected to one unit, so for example you are placed into the CD unit, you might also have a block flow diagram designated for the CD unit. One example that I have is the picture that you have on the right hand side, which shows a CD unit. And one key element that I want to tell you here for the block flow diagram is that the block flow diagram shows the input and output. So here you have the input as the crude, you have the output here from the CD unit, all of the different outputs. And also another concept is that for those outputs, usually If it is for a designated unit, then the lightest component will be on the top and the heaviest component will be on the bottom. So this is also, if you are presenting a distillation column, it will be represented in this way as well. And another concept also to be added for the block flow diagram is that how is the flow of the unit is that it starts from left to right. So as you can see here, the process starts from the crude from the left hand side, then it goes into the right hand side. So here you have, for this specific block flow diagram for the CD, you have the first preheating unit going to the first stage desorter, second stage desorter. The second preheating unit, you might have pre-flush drum, another preheating unit, heater, and then going to your CDU column. Moving on, here it's just a definition I got from a standard, and it gives you basically a definition of block flow diagram, which is, it is a block that depicts a process or process plant consisting of rectangular frames. So what we said before is that block flow diagram, it's basically a diagram with different blocks, and those blocks are being connected together. The key idea here is that those blocks and frames could be representation of processes, they could be a representation of unit operation, process steps. So what we said before, like it could be a representation of a whole refinery scheme, it also could be representation of within one refinery unit. Another concept I wanted to introduce is that the block flow diagram also sometimes have, or it might include information about the mass flow rate. So here you have this mass flow rate, 100 kilogram per hour, and it could have information about temperature and pressure. Okay, so now let's move to process flow diagram. Process flow diagram is basically a diagram which is more complicated than the block flow diagram. Now you have more details, and the difference is that the block flow diagram, as we have seen before, it is consisting of basically different blocks. When it comes to process flow diagram, one notable change is that it consists of graphical symbols. So now you don't represent your equipment as blocks, you represent your equipment as process equipment, graphical representation. And the process flow diagram shows you a snapshot of the steady state process, so how those units, basically the flow rate within the steady state process or the operating condition within the steady state process. And if you want to know how the graphical symbol of different elements, equipment within your basically your unit, you could either refer to the legend P&ID to see how those equipment are basically will be represented. But one very generalized idea, if you are designing, is look into standard, and one good standard is known as the British standard 1553. And I got this image from there, and it shows you basically some valves which is being placed. So here at the top you have the inline valve, you have the angle valve, the relief valve, and this is another example where it shows you the knockout drum, different configuration of tray columns. And one thing I wanted to show you as well for PFD is that the PFD might have, if you are transferring the PFD or building the PFD from process simulation or HYSYS, in the process simulation and HYSYS you will have mixing points and split points. So if you want to transfer this information to a process flow diagram, you should not transfer the mixing points and the split points, because this is not actual a capital equipment or any equipment. It's basically line of pipes that will create this turbulence. So something like this here is like a split point. In simulation it will be different. When you transfer this, it will be just lines. And here also you have a mixing point, and this will not be transferred to a PFD or P&ID because it's not really an actual equipment. If the equipment is actually a mixer, it's a capital equipment, then it should be included. However, those mixing and splitting points, usually they are not they're not capital equipment. So how to know? Basically ask yourself the question, is this a capital equipment? So a capital equipment is something like compressor, pumps, vessels, distillation columns, reactors. Those are capital equipment. All of the capital equipment should be added. Otherwise, you should not add non-capital equipment to the process flow diagram. And also another thing is that the operating condition will be added in. If you have this equipment over here, so here this equipment is denoted as 30 TK 101. So basically, just to give you an understanding, this 30 is the unit number, so the unit number is 30. TK is the equipment letter, and 101 is the serial number. So basically here what it means is that the unit where this tank is existed at is 30. The equipment is tank, so it is represented as TK, and the serial number, the number of this tank, is 101. If this tank is being represented in the process flow diagram as 30 TK 101, so then when you transfer it to a P&ID, it should be represented with the same tag. So this is what I wanted to mention before I move to P&IDs. Let's go back. So now when it comes to P&IDs, P&ID is basically something which is, as we said, it's more detailed than the PFD, and it's an acronym for piping and instrumentation diagram. And basically it shows you all of the elements within the unit that you have. So as we said, any flange, any mechanical connection, any manway, anything, any instrumentation should be included in the P&ID if actually it exists in reality. Okay, so here in this slide is basically the different anatomy of P&ID. So here in the middle you have the main body, which all of the equipment, all of the elements will be represented here in the main body. So all of the pumps, the vessels will be in this part. In the top you have the callouts. Also sometimes the rotating equipment is being placed down. And basically any element which exists in the main body should be also represented in the callout section. Another thing is that you also have the notes and hold section here. You have the reference drawing. The reference drawing is basically a drawing that shows all of the documents that you should read before you look into this specific sheet of P&ID. So it's good to have it while you are reading that specific sheet. Also you have the revision block and the title block, and we will look into those information in greater detail. So now let's go back to this diagram. So here the static equipment is being placed at the top. This is in some cases, and also the rotating equipment is placed in the bottom. You might have cases where all of the callouts are being placed here, including the rotating equipment. So both static and rotating being placed at the top. So this is just one representation. There are other representation. Also this here, the notes and hold section, the revision, all of this block, rectangular block, is basically sometimes it's placed in a vertical way, sometimes it's placed in a horizontal way. So just for you to understand that there is different forms of P&ID. Another thing I wanted to mention is basically the grid system. The grid system is, as you can see here, the letters along the top. So along the border of your P&ID, you will have letters and numbers, and basically this gives you freedom to know what exactly your equipment is. So it helps you to aid communication, and this is sometimes very important, especially when you are speaking to other engineers. If there is a lot of equipment in the P&ID and you want, for example, to represent your pump, and this is pump B, so this is pump 102B, and you want to tell the engineer to look into this specific pump. So this pump will be in G, and it's 7. So you say, okay, I want you to look into pump 102B, G7. So he knows that if he goes to this sheet and you tell him the information of the sheet, so let's say this sheet is sheet 100, and you say, okay, P&ID sheet 100, go to pump 102B, G7, and you state what is the actual issue, what you want him to do. So it helps you to aid understanding. And sometimes this grid system is also noted in the streams leaving the P&ID to show where the stream is basically going to. So now we will look into the concepts of revision block, and I will actually show you a P&ID to be familiarized with this idea in more detail. Okay, so this is the diagram that I wanted to show you. As you can see here, we have the revision number. The revision number is revision number 4, and the revision number should be the same as the one which you have here in the revision block. So if you have here number 4, the latest revision you should find in the revision block is revision 4 as well. If you are seeing here 3, the latest revision should be 3. You should not have some inconsistency between what is placed here in the title block and what is here actually in the revision block. And as you can see here, there is different issues, different revision. There is one issued for construction, one issued for approval, HAZOB. So we will look into those concepts right now. Let me just return back to the slide. Okay, coming back to the slide section. So as we said before, the revision number in the P&ID should be the same as the latest revision number that we have in the revision block. And also a concept that I want to introduce is if you want to start now building your own P&ID, so the first step basically to either start with a blank P&ID or either start with a go by sterilized P&ID. So a go by sterilized P&ID is basically a P&ID where you have got from previous designs, and this P&ID is very similar to the design that you have currently. So this is why it is go by sterilized P&ID. So you're not starting from scratch. You already know that this project is very similar to this project, and you keep changing the tags and the equipment tag and the instrumentation tag to fit your new project. Okay. Now let's move basically to another concept. So here in this section, basically, if once you get your go by sterilized P&ID, you change the different elements. So what happens next? What's the different revisions? Is that first you will start with the first revision, which is issued for review. And this is where you as an engineering company will kind of finish the P&ID, but like as relating to your new design, you have completed your P&ID, and you want to show this P&ID to your client, and you will issue this P&ID for review, where the client basically will come up with the with markups and comments for you basically to look into and change them before you issue your next edition or next revision. So in some cases, what happens is that the engineering company, they will issue another type of revision, which is issued for internal review. And issued for internal review is basically when you want to discuss as a team without the presence of the client. So before you present this P&ID to the client, you want to make sure that it is approved from your team and you have decided the major elements. So in some cases, some engineering companies will do the issued for internal review before they do the issued for review revision. Once you have got the markup, you have changed some of the comments that your client have provided, then in this case you will issue for another P&ID, which is issued for approval. And in this case, you are looking for the approval for the client, basically to finalize and approve the major elements of within your P&ID. And in this stage, your client might come with further comments, things that they want you to change. There might be some changes before they approve, and you, as the engineering company, you might basically negotiate with your client either to negotiate if they why have you taken those steps. So there will be some negotiation and communication with the engineering company. If they are approving that, they will approve the P&ID. Otherwise, you will do the changes which is required, and then at the end of the stage, the approved. So once you get the IFA version being approved, the next stage is basically you will go issued for design P&ID, and you might ask the question, is that the P&ID that you have constructed for approval, is it not adding the design elements of the process equipment? And the answer is yeah, most of the design elements is being completed. So when I say issued for design, I mean designed by other discipline, not the process engineering discipline. So disciplines like the instrumentation, mechanical, like control, those departments will look now into the P&ID, because you're saying, hey, I have approved, I have done my part in terms of process equipment design. I have approved those with the client, and they said we can continue. So now, since we have approved the major elements, you can start with your design. So this is why this is done in this stage, basically. And in most cases, before you do the IFD, you will do something known as issued for HAZOP. And this is done before the IFD, mostly because you want to basically look into the design issues that might happen. So issued for HAZOP. HAZOP is basically hazard and operability study, and it's a meeting which is done for several days where engineers will meet and they look into what can go wrong within your process equipment, your process design. So it's a very good idea basically to do the issue for HAZOP before the IFD. However, in some cases you're not able to do it because let's say, for example, you have a schedule issue, lack of time, and some elements you are not really sure of. So sometimes the IFH will be done after the IFD stage. Once the design is being done now by the instrumentation and by the control and the mechanical team, now you will issue the P&ID for construction, and this is where you will start building. So after the IFC, you will start building your chemical plant. Another thing I wanted to mention is that in most cases that the client will require you to do cost estimation, and in this case they have the client will have some go and no-go economic gaze, where they want from the cost estimation to basically know if they will go with the project or they cancel the project or they will keep the project in hold. So some cases it is required to do the IFE, where some engineering company will issue the IFE for the cost estimation. However, in most cases is that the latest revision of P&ID will be sent and cost estimation will be done based on the latest revision of P&ID. Okay, so the last type or the last revision is basically the as-built, and the as-built is basically once the chemical plant is being constructed, then what happens is that sometimes you have some construction constraints, some elements are not built as it is mentioned in the P&ID, and there might be some construction constraints and the client will change certain elements. So if there is any changes, the designer will issue as built P&ID, and from its name it means as it is built. So if it is built in this way, it's gonna be labeled in the P&ID as it is in reality. And in some cases for legality, they don't say as built, they say as recorded, because the difference here is that as built is when you send physically an engineer to do line tracing. So in this case, basically the engineer will follow all of the lines that you have in refinery and or the chemical plant, and he will come up with the comments in the P&ID. And those changes will be made and the as-built revision will be issued. However, in some cases, it is not done by an actual person, it is done by virtually by cameras, and in this case, it is labeled as recorded for legality and to protect the client, and it just means that it have been recorded virtually. So this is the end of the first session. I think I will continue the other parts of the P&ID in part 2.